Good evening, everyone. And this is my honor to. This actually is my first time to come to Milan Polytech, and it's my honor to be here to present China Pavilion to all of you. And the project itself is under construction. I just come from the site. It's very tight. You see, I drink a lot of water, so it's very dry on site. I'm like what Lola introduced. My name is Yichen Lu. I'm an associate professor from Tsinghua University. I'm also the chief architect of this China Pavilion. I'm also the principal of Studio Link Arc in New York City. We are in charge of the architecture design part of this pavilion. So today I would like to introduce our studio in a very short speed, and then we will focus on the China Pavilion. First of all, I will talk about the concept of this pavilion. Then I will talk about the programming, the circulation. Afterwards, I will talk about the most interesting and the most challenging part for this pavilion, which is the roof system. And then I will talk about the entire construction progress. I think you guys are very interested in that part as well. So before I start my own company in New York City, I work with my studio advisor, Frank Gehry, start from 2008. This is one of the projects we worked on is the Guggenheim Abu Dhabi. Then at 2010, I moved to New York City with my family to also working with Frank Gehry, working with Stephen Hoare. This is one of the projects I work as a project manager. It's a concert hall and a museum project in Hangzhou, China. So at the end of 2011, there's two options for me. One option is working as one of the two directors to running Stephen Hoare's Beijing office. Another option is doing my own studio in New York City. So I chose the second one. It's very challenging and also very rewarding option. So this is a cartoon made by Leon Carrier. So it's talking about 15 years later how the architecture looks like. But for me, from my perspective, it's more like my understanding about Chinese architecture industry and American industry. So for China, there's lots of muscle and they take action very quick, but almost you don't have time to think about what you are doing. So in American, it's very brain power, very strong, but without enough muscle to support their action. So what my thoughts is, the studio we have set up in New York City is we're going to create a platform to make a very good balance for the strengths and the weakness of the Western and the Eastern. So that's the reason why we set up our office in New York City. So our efforts get rewarding very quickly. So this is the clubhouse we did in Guiyang in China, which is already finished the construction. It's about 8,000 square meters. It's our first project in China to be complete. This is a very small 2,000 square meter clubhouse gallery, and it's under the construction, will be finished by the end of this year. Then this is another master plan which we did for the second and the third phase. It's 550,000 square meter residential master plan. And the first phase it did by Norman Foster, and we are doing the second and the third phase. So the second phase is almost finished the construction. This is the image we took at the beginning of last year. And the third phase is under construction right now. So the marketing and the construction speed goes very fast. And this is I think it's 350,000 square meter residential. It's not residential, it's a commercial area developing competition we did together with Norman Foster, RTKO, SOM. Actually, we got the second prize. The first prize is Norman Foster's. They got 8 votes. We got 7 votes, and RTKL got 1 vote. In total, it's 16 votes. So at that time, the clients want to give us these 2 buildings as a commission to be built, and we actually refused because the size is too big, and I don't think we can control such a big project with a good quality. And this is one of the reasons. Another reason is at that time we win the competition of the China Pavilion, and which is happened by the end of 2013, I think. So from now I will start to introduce about the China Pavilion design. So this is the site. I think everyone knows about it. Probably you guys are more familiar about the site for me. So here is the China Pavilion, which is the second largest pavilion in this expo. And we did a couple of very interesting diagrams. This diagram shows the China Pavilion is the second largest one, and the largest one is the Germany Pavilion. And this is the master plan. You will see there's a channel is behind the pavilion, and the main axis will be in front and the south of the China Pavilion. And this is the area. And it's very interesting. We start the site with this L shape. At the end, this pavilion, this national pavilion, they quit. We have nothing blocked our view, and as we are thinking about, we probably can use this area to do doing some landscape, but the Expo they refuse that. So now I don't know exactly what's this land going to be. So from now on, I want to talk about the Land of Hope, which is the theme of the China Pavilion. At the really beginning, it's I think a lot of students. There are a few students are from China. I guess. So you know this music, "The Land of Hope." It's a very famous song at the 1980s. At that time, the country just opened the entire market to the world, and there's a couple of big evaluation at the time. So one of the big evaluation is the agriculture, the farmland. So the farmers, they are allowed to own their own land, and then to start to have their own agricultural action. So this rule actually actively lots of the people's power for their own working. So there's a lot of movie about this action, about this evaluation. One of the movie is seen by the current First Lady of China. The name of the song is "On the Land of Hope." So the client make this topic as the theme of this pavilion. I think it's very interesting. So my office is a very global office. We had people from all over the world. We have Chinese, Japanese, Korean, we have Greece, and we have people from Germany, from Italian, and from France. So I give them assignment. Everyone should provide one image about what means the field of hope from their perspective. So you can see that's some of my career students they found. And the field of hope could be rice, and it could be the bioeconomic diagram. It could be the biomedicine. It could be the food industry in South China. It could be the land. So we are thinking about using a very traditional way they call 5-color soil of China. We try to make a wall like five-color soils. And then we realize, okay, in China there's a 97 type of different color of soil. It's too much, the entire country is too big, and with a very big, magnificent traditional cultures. It's very difficult just using one concept or using one material to include the entire country. So we kind of give up just from some idea. So this is the image I found. I really like it. It's a very warm image for me. So we are thinking about how to express the China Pavilion from the other way. Another thing we are thinking about, instead of we are doing an object like a British Pavilion in Shanghai Expo, we would like to do in a design is more about the field. So on the right side is a very famous watercolor done by a Chinese artist name is Wu Guanzhong, I think. So this is a small book published by Princeton Press. It's all about the Sightless. You will see it's a kind of manual and a catalog for all the different form of the objects. So we did a study about how to play the game between the field and objects. We have a field of objects. We had field as objects. We have objects as field. So you will see. So it's kind of a game, play with the section to show the relationship between the objects and the field. So this is the progress model we have. So you will see we're kind of getting to what we want to express. So eventually we trying to create a roof line, which by connecting the skyline of the Beijing CBD and a contour of the mountain range in China. So we merge them together and create a loft and push the north surface to create a deep facade. So you will see how this form comes from. And this is the section cut from the south to north. And the entire building, you will see on the source, you will see the profile of the mountain, and on the north, you will see the profile of the city. And then there comes this rendering. This is the composition model we have. So then I'm going to talk about the program and circulation. The entire program for this time China Pavilion, I guess, is one of the most complicated program in this expo. The clients spend a lot of focus on all the exhibition design. There's 11 different provinces provide their own exhibition in this area. So the people start from the south and they're gonna come in. Here is the stage for the visitors. When people come, there's a surface area, and this is a 11 province exhibition area. And the people start from here, they're going to the second floor, and on the platform, they're gonna look back to the land. You'll see the entire section. The people start from, they see the landscape, and they start to walk into the landscape. And the landscape elevation become part of the exhibition elevation. Until they get to the second floor, they will see the entire field of the landscape. The plan is going to be like the famous video game. So it's kind of you are eating the stuff and occupy the space. So that's the reality of the video game. People in the surface area, there is some exhibition about how people cooking the Chinese food. And then there is some exhibition area. And when people get to the second floor, they're gonna look back to the field. There is a 22,000 piece of LED stick on the ground. Each of stick is actually is a LED equipment. So basically, it's a horizontal big LED screen. You're gonna keep changing the image and showing the people's life in China and the farm image of the farmer and the agriculture. So after people on this platform, they are going to get into the auditorium. There will be a movie about 10 minutes to talk about story of Chinese Spring Festival. Then people going out from the space, from a bridge above the roof, then come back to space, go to the exit area. So that's the exit area. So at the very beginning, we are thinking about using this area as entrance, but at the end, we think probably we can keep the most monumental space at the end of the circulation. So quickly introduce the program and the concept of this project. The reason is what I think is the most important and the most challenging part for this project is the entire roof system. The roof system is start from bottom to top is 4 layers. The bottom layer is a glulam structure system. Above that is a waterproof layer. And between the waterproof and the structure system, there is a system for the bamboo panel supporters. And on the top, there's a parametrically designed bamboo panels as a shading system. So it's a very typical and very challenging sandwich system because the more supporters get through with this waterproof layer, the more risk we're going to have the leaking issue. And also how to build the entire wood structure according to the concept, the loft concept we have. It's a very serious parametric issue, and also for the construction as well. So this is a very original concept we had. This is the wood structure, and we are going to have a supporter to capture the waterproof layer in the center. And from the waterproof layer, we are going to have a supporter to capture the bamboo panel. It's a very difficult issue. So for the structure, the concept is based on the traditional Chinese structure system, which is called raising beam system. So we are trying to use the contemporary glulam technology to express the traditional culture. So you will see the entire building is floating above the landscape. And we try to minimize the section of the column and try to have the column as small as possible. So the entire roof floating above the landscape. And this is part of the competition model. You will see how we reduce the column and create a big span for the exhibition space, which give a lot of challenge for our structure engineer. So our structure engineer, at first we had SGH, which is a New York-based structure consultant company. They are very experienced. They start to do the Expo Pavilion at 1979 at the Montreal Expo, I think. So they help us a lot to develop the structure system. Actually, as similar with the other very ambitious structure engineer, at the very beginning, they are thinking about give us some very strong and very ambitious structure diagram. So we give them 3 comments. The first of all, the structure should be considered about the budget. The second one is the schedule is very tight. We have to follow the original concept, which is the profile of the mountain and the profile of the city. We should keep this idea in there. The third one is instead of we are doing a very self-expression structure analysis, we prefer the structure merge into the space to be part of the space, which I think is very different with the other American architects. For example, when I work with Frank Gehry, he's project is very expressed himself. But for us, for me, the space is more important instead of just the form itself. So as judge, at the end, they gave us some other idea. For example, this is one of the idea they call 5 trusses. So from north to south, there's a 5 trusses, and actually it's turning the angle from north to the south. So this 5 trusses, it's like a Chinese biandan to span the entire building in between the core and the north and the south. And also there's in order to reinforce the entire roof structure, we have 6 rafters, steel rafter from north to south. So we call this is rafter to reinforce the entire roof. So at the end, the entire project is merge these two together. You will see the entire roof is very difficult. You have so many steel structure and the wood structure combined together. There's also a very difficult moment I remember is at the middle of last year. Because our structure engineer, they start to put 12 steel cables inside of each purlin. The purlin, which means purlin is this small piece from north to south. So the entire roof, each purlin meter rafter, there's 2 joints. The entire roof, there's 1,400 joints, and each joints are different. So in this case, if each joints and each purlin has 12 cable in there, which means the entire roof, to be honest, it becomes a steel roof. So it's very terrible moment I remember at that time. We spent almost a month to discuss with our structure engineer and the engineer in Italy. And then we found a better solution, which is increase the depth of the structure from 460 to 560. With this 100 additional dimension, the entire roof can be less rigid, and we can use another system for this roof. So you will see the diagram when it's kind of like a game when purlin meet with rafter, when steel meets wood, we have a diagram to show all the different situations. So you will see we had tons of the sketch in between Italy and New York and China. We try to throw this out. You will see this is one of the very typical joints. So this is steel, and you will have a plate on the steel. And each wood, you have to CNC a pocket to have this steel inside of this wood purlin. And then for some reinforced part, you also need a steel cable there to reinforce this area. So this kind of joint in total is 1,400 types, and each one are different. So this is one of the largest steel plate, which is, I think it's 1.2 ton or something. You have to have 5 people can carry this. So this also makes us very nervous. So we talked with our timber structure engineer. We said, okay, we can simplify the roof for you. We can use parametric to help you have at least 50% of the timber structure are same, which means we're gonna help you to speed up the prefabricating progress. But make me very surprised is our Italian timber structure consultant, the fabricator, they refused. They said, by the CNC machine, there's no difference. If you cut each section different or you keep them similar, there's no difference. So you will see that's one of the mock-up we have. So basically, all the pockets is hiding behind this timber structure. You won't see this from any other outside. Another discussion between New York, Germany, Boston, Italian, Udine is the material called LVL. Because our structural engineer in New York, he's Germany and a graduate from ETH. So he highly recommended one material called LVL, which means the wood material is glued like this way. So you have horizontal one, you have vertical one, you have horizontal one. So they create a very big chunk of the wood, and you can have a CNC machine just cut the rafter very quickly. And then we got the information from Italy, and our Italian cooperators, they are more comfortable to using the material called glulam, so which is above. So we have to make a decision. We have to either choose the our Germany consultant or from Italian consultant. Actually, we have a big chunk of the LVL in our office. We're using this as a chair right now. It's basically structurally, it's very strong, but I don't know the Italian fabricators say, no, there's no way to do LVL. We have to do glulam. So we trust them. So we went to Udine. There's a company called Stratex. And we went to make sure they had two things. One thing is called dynamic mold, which is a mold they can create very quickly in 2 hours to build the rafter, to bend the rafter. And the second machine, of course, is the CNC 3-axis CNC machine. In this case, they can cut the section and they can cut the pocket by the machine itself. So as long as they have these two systems, I think they will be fine to make this wood structure. It's a very difficult decision, and we spent like 6 times of the travel in between New York and Italy. And we even try to control the texture of this glulam, because when the rafter to be break down, we want the texture still can be continuous. Also, you guys will see there's a gap here in the construction they call shadow gap, because if during the construction it's not flat, you will see the shadow over there. So they create a 5 millimeter 45-degree cuts to hide this shadow. So we spend almost 1 afternoon to negotiate with them to reduce the dimension from 5 millimeter to 3 millimeter. It's very interesting to have a negotiation with the Italian consultant. And another story is we spent 3 times of the trip to decide the color, because the wood color is very strange. If you look at the inside, you look at the outside, you hang this above, the color looks actually different. And if the wood exposure at the exterior for a month, the color will be much darker. So when I first go to Stratex, I said, I like the wood in your main space. He said, it's 20 years right now. And then this is 3rd time when we go there, they hang the mock-up to 12-meter height and rotating this material and let us do the final decision. And eventually we chose the most light color, which is 1 coat of water base, and almost like a nature color. It's a little bit darker, but when you exposure this at outside, you will get a little bit darker in the end. So everyone was very happy at the time. They're shaking my hand and saying, you make a very good decision. I'm so glad to see that. And here is Claudia, and he is the principal of the Stratex. And this is Laila, and he is from the Bodino, which is our general contract. We had a lot of good story with her, and I very admire her. So you can see this is the construction process. The wood structure is start to putting together in a good shape. And you see this cable is still there. And there's the exit space during the construction. It's very interesting way is we never simplify the shape of the roof. So you will see this kind of hard edge is part of the transaction from the city skyline. So you will see a very strange sharp cut at there. So they exactly built what we have in the computer. So that's the piece people working on the northwest corner. Another story between for the steel structure is one night when I in Torino, I tried to call my general contractor Laila. She is the project manager. I want to have a dinner with her, and she said, "I'm sorry, I cannot have dinner with you. I'm on the way to the steel fabricate company," because she was realized there's one plate inside of the steel structure. It's very heavy. It's almost like 2 tons or something. And for her understand, it's very difficult to have this inside of the structure. She was very nervous about it. So at, I think, 9 p.m. or 10 p.m., she drive all the way to the factory to look at this detail and the joints. And the second day, she said, "Okay, I think that's fine. We can make it." So you will see the fabricating progress. So the people have the cuts on the steel and they bend the steel and put them welding these together. Another difficult part is the joint. And here you will see when they welding the joints, they doesn't leave enough space to keep this very flat. So you will see the welding joints on side of this above this surface. We are not very satisfied with that. So the company, they promise they're gonna start from because the construction is start from north. They start from the third steel rafter. They are going to use a new technology. So it's very interesting. If you go to the site, start from north to south, you will see the quality of this steel rafter is 1-to-1 is getting better and better. So this is the south part, and you'll see it's very interesting way because without any purlin, the rafters stay by itself, and the supporter just by the scaffolding. And the shape of the steel is very strong, express our idea from the nature's skyline to the city skyline. You will see the Alpes mountain from very far away, and our building kind of have a very long distance dialogue with it. I remember when at 2008, I'm working with Jean Nouvel for a competition, and it's very interesting. It's a bridge competition, but Jean Nouvel extended all the program of the bridge to the city. Actually, he switched the bridge design into a master plan. So he said, okay, if you're doing architecture, you always need to think about the city. You do a small project, but your imagination, your concept can be projected to a far away. So I think I kind of like this image. You'll see the dialogue between the nature mountain and with this artificial building. So the second part we want to talk is the waterproof system, which is the most not visible, but it's also very higher technology requirements layer. So for the parametric design for this paneling system, there's a two-way. One way we call all unique panels. So it's like a Zaha's building. So the space between the structure and the surface, they are all same. In this case, each panel will be different. So which means the entire construction budget and the schedule will be much bigger than the other project. So we cannot do that. We have very limited budget and the schedule. So another way is like the Spanish pavilion in Shanghai Expo. Each panel are same. In this case, which means the supporter between the structure and the panel will be all universal. So in this case, which means lots of construction time, and also you cannot make sure the entire roof as smooth as what you want. So what we have to do, we have to using the parametric to finding a balance in between the all unique panels and the all same panels. So this is the surface during the competition phase, and the right side is the control surface in the construction phase. And also very interesting, we're finding a hiding line on this surface. because this line is not really parallel with the purlin, and this line actually is helping you define all the supporters. So when we unfold the entire roof, you will see it's not a rectangle, it's kind of like a piece of transparent skirt. And all this blue line is the direction of those roof panel. And the red spot is the support area. You will see the entire shape is very interesting. So the way when we do parametric design is very different with the traditional way when we design something, because it's nothing about the form or nothing about the design. It's all about how you have a very clear mathematical system to create the entire roof. So the parametric designer working with us, he's my coworker and is teaching at the SciArc right now. He used to work with Tom Mayen for lots of Tom Mayen's projects. So for him, if I ask her, can you change the panel from 18 degree to 17 degree? He said, there's no degree in this surface because it's 3D, right? I only can tell you I can reduce one panel on the south and reduce one panel on the north. So it's created by the computer itself. So we're using processing to do a lot of testing. So the responsibility for architects is less about the design, it's more about the make a decision. So we have to find a very clear system. Then we judge this system to find the final solution. So another interesting story is about the waterproof material. Our consultant is from Shanghai. So they highly recommended the curved glass material in China, which can be fabricated very quickly, and also it's making me very surprised. It's very cheap actually from the budget that we saw. And then another material is our Italian general contractor. They highly recommended the solid polycarbonate. So they have a fighting in the Skype meeting, and our Italian consultant promised he had 2,000 of way to resolve the problem of polycarbonate. So my Shanghai consultant, actually they are very experienced as well. They are doing the highest skyscraper in Shanghai right now. So really, they really admire that. So they said, we really want to see this 2,000 solution, how they can work. So they gave up. And our Italian consultant, they start a study for the polycarbonate. But when we go to Turin, they give us another option, is a PVC material, which is the right side. The left side is polycarbonate. It's very interesting. They make the PVC material mock-up, put in a very nice place, put a light on the back. They hide in the polycarbonate sample on the corner, a very dark area. They want to push us using PVC, and then they come to ask, which one do you like? I said, polycarbonate, of course. So, really? Why? So I think it's beautiful, right? You not only have the shadow, you also have the material reflection on it. It's so beautiful. You see they make this supporter in a very ugly way and have a very ugly supporter detail there. So we had almost 2 months to negotiate with, we are using PVC or using polycarbonate. It's a long story. So at that time they said, okay, if you want to use polycarbonate, all detail you have to draw the shop drawing by yourself. If it's leaking or if it's broken, it's not the general contract fault. I said, come on, please show one of the 2,000 solution to us. Right? So it's a long discussion, and at the end we decided, okay, we have to compromise because of the schedule. So we are using the PVC material. Yeah, that's our sketch did by our structural consultant. So at that time, you will see that's a curved glass solution. We will have a gasket to press the glass to make sure the water is not going to get into the space. And this supporter comes up to capture the bamboo panels. But the problem for this detail is the entire roof is 3D shape. So you never know where the gasket cannot really fit the space. And also the height between the waterproof layer and this beauty cup, they had the risk to have the water leaking over there. So this is the final decision. When we have the PVC, you will see there's a much refined detail over there. So basically it's something like this part. And the supporter is going to sit on the aluminum profile. So you will see this aluminum profile is well done, and also it's going to do exactly follow the rafter for all the 37 rafters. And you will see the constructors, they are working on that part. For the joint system, I can go a little bit faster. So this is before the parametric. You will see all the different color means the different height of the supporters. So after parametric, we can have a much less type of the height of those supporters. And that's before the parametric. That's after. You will see we only have much less type of the supporter heights. And each supporter, they have different responsibilities. They're going to capture 2 panels. They're going to capture 2 panels by itself. And at the really beginning, there's triple joints. One supporter going to capture 3 panels. And this detail is already limited. We only have these 2 type of the panels right now, the supporters right now. You will see how busy, especially the north area. Each red point is one type of the supporter. So this each location of the supporter need to be very precise. Otherwise, the bamboo panel gonna shift the direction. And that's the contractor. They are working on the PVC. Actually, these workers, they are from Germany. Actually, their professional is the clamping, the mountain clamping. So they're not the regular workers. They are very special tools. I try to have it. It's like it's pretty heavy. It's very difficult to get onto this roof. So that's the most exciting part, is the surface of the entire roof. So that's the grid line we create for the panelization and the folding. And then we do everything in the parametric to processing the entire roof. But in this case, at this moment, each panel are different. Then we have to rationalize it. So each color is one type of the panel. You will see from south, we have more similar type of panels. From north, most of the panels are different. When we zoom in, you can see each panel, we have a specific angle and the size. One color, one panel, one type of panel. And for the parts, people not gonna see it, we're gonna repeat more panels over there. So we had a flat panel, we have one fold panel, we have a trimmed panel, we have 4 or 5 types of the shape. And then that's in total panels. And we make a dialogue to create a list for it. You will see there are some panel have 2 15ths and 16/1, 54, 23rd, and these are all 1. So in this case, 1/3 of the roof, they just one type. And another 1/3 of the roof, they can with more than 10 types of types. And the rest of the 1/3 of the panel, each piece are different. So in total now is 1,052 pieces of the panels. And we even make a mock-up in our house. We try to figure out how to put those panels to avoid the overlapping. We even made a small handbook for the roof. It's like a manual, construction manual. We deliver this to our Italian contractor. I hope our roof can be installed like IKEA furniture. So without thinking, you just put it on it with all the numbers and the system. They really like it. Actually, in-house, the book name is Detail. So So this is one of the model. We're testing the size of the panels. You will see each panel is 3 meter long and 1 meter width. It's larger than people's size. But we also have to control the weight of the panel, because if it's above 17 pounds, I think, you have to have 3 workers on the roof, which create lots of risk for the construction. So we have to make the panel as light as possible. So you see the size of the panel. So during the construction, the client asked the question for what type of material it is. At that time, we are thinking about using the metal mesh, which actually metal mesh, you can bend it during the construction. But considering about using more sustainable material, because we're using lots of wood, OSB, so we are thinking about using bamboo as the entire roof. It's also, bamboo has a lot of meaning in Chinese traditional culture. So this bamboo system going to create a shading for the interior exhibition space. We tried our best to eliminate the curtain wall around the edge, to have the nature ventilation come into the space to cool down the exhibition area. So in this case, this shading system became very important. So I went to Zhejiang. Actually, in China, there's 4 big provinces has a lot of producing for the bamboo material. We decided we are going to use one type of the bamboo strip, and there is, I think it's 90,000 meter long bamboo strips, cut by 2 meter by 2 meter, shipped into Italy. And it's also a sandwich system. There's an aluminum frame in the middle, and the bamboo strip on the top, and another regular bamboo strip on the bottom. So we start to testing the different patterns. And then more and more we realize, instead of we have pattern, we have, because there are some suggestions used in traditional Chinese bamboo pattern, we think instead of we have pattern, we more prefer the texture. Because with the texture, we can define, okay, I want 65% of perforation, or I want to 70% of it. So it's nothing about the pattern, because on the roof, it's an entire system. So in this case, we chose the most simple one, which is in the center. So we will see from the exterior, all those bamboo patterns, all those strips, they are exactly follow the shape of the bamboo, go all the way to the north. And from the inside, you will see those bamboo strips create a very interesting surface. It's like a sketch at the interior space. So although we have a parametric tool, each panel, you have to doing a one-by-one check manually, because that's a problem for a computer. You can create a form, you can testing everything without tolerance, but the problem is the gravity and the materialize and the construction tolerance. Or parametric designer, he's from Japan, so it's a story I always want to talk. For him, there's no tolerance, so he do everything perfectly. So no tolerance, each line is matched to each other. So our Shanghai consultants, they have lots of experience. So they said the tolerance up and bottom, 25 millimeter is acceptable. In this case, it's 5 centimeter tolerance. And our Italian consultant said 1 centimeter tolerance is very regular in the construction. So we have no idea who we can believe, right? So in this case, architect become a judge, right? You have to make a decision, very quick decision, to say, okay, this time I'm going to believe the Japanese, this time I have to believe Italian, and this time I believe our Shanghai consultant. So it's a very long distance and the long term of the discussion between the different aspects. So you will see this aluminum profile is built in Candon. And they made mistakes because they had a number on it. When we spray the color, they forget to cover the number. And in this case, there's 400 of the panels without number on it. And you have no idea how to measure it to find out what exactly it is. So the Chinese general contractors, they pay some fee for the Italian general contract to find exactly these panels. Spend almost 2 months to do this part. And then all those bamboo strips shipped to Italy, you will see they really like a professor sit in front of the table and have a very systematic paper to put each bamboo on it. I kind of really like this image is how serious they put this bamboo together. And the quality is pretty good. So this is the mock-up we had in Torino. At that time, this is MDF. It's not bamboo yet. And for the made for Expo exhibition, which Lola as a curator, there's a mock-up over there. Just 3 days. Yeah. So it's kind of exciting. We see this mock-up over there. And you will see at that time, see those strips and the shadow creates between these 2 different part cabinets. This is I and my colleague. So the entire roof, we create 6 different areas. This is the southeast area, which is the main view area. There's a bridge above it. This is the exit when people finish the auditorium, finish the cinema. They're going to come out, stand on this bridge, look at the field, and go back to the space. So it's like that. So this is the view from the top. You will see all those bamboo strips is almost seamlessly connected together. From the southwest corner, there's a souvenir center here, and the exit space is over there. This is the middle part of the auditorium. You will see the entire roof create a very beautiful cuts from the back. So this is the edge of the auditorium. People are gonna go out from here. And this is the exit space. This middle part on the west. Here is the office. There's a VIP entrance. This is the VIP VIP space, and the 3rd floor is office space. You'll see how this waterproof layer working together with the bamboo strips. And this is the wheat straw. In total is 44,000 pieces of the wheat straw. And this is the reflection. And the north part, there's a banquet hall for the restaurant on the 2nd floor. This is the edge of the southeast corner, and the light from the west. So entire project is very complicated, and start from the clients make decision for the general contract to the project to be complete. We only have 7 months to finish the project, start from 0. And when I went to Domo, I saw there's a flag of China. And on the left side, there's Wangfujing Street, which is the most famous commercial street in Beijing. And there's a roadshow. Actually, there's 7 different roadshows in the 7 important cities of China. So this pavilion became a very important opportunity for both of the country. So there's a couple of very serious documents we have to submit at the very beginning. We don't have site supervisor, we don't have general contractor. So my New York office have to do everything by ourselves. We write a report for the site manager, we write a report for the safety of food and everything in Italian, in both of Italian and English. So you'll see the project credits is very global and a very interesting way to arrange these different parts together. The more teamwork, which means you have to spend a lot of the more efforts to communicate with the different parts. This is only the design part, not including the construction yet. So we're working with our Italian consultant and the fabricator. And this is Luigi. He is very experienced. He worked for Renzo Piano for lots of curtain wall design. And we usually have some like a long-term meeting, especially when I teach at Beijing, because the Beijing time is in the Beijing is 6 hours before Italy, and Italy is 6 hours before New York. So when in Beijing, I want to have a meeting with Italian and both of Italy and New York, I have to do at 11 p.m. So it's very difficult time for almost 3 months during the time when I'm teaching over there. So entire construction going to start from north to south. You will see the general contractor provide how those cranes can working together to create the roof. We call this dynamic construction because you cannot wait the architecture part to be complete. When the roof waterproof layer finished, the interior guy have to come in, and the exhibition has to come from the other side. So, and the landscape from the north. So it's very dynamic way working together, very tight schedule, and very challenging for everyone. And I would like to show you some construction photos. That's the wood structure almost finished. That's 2 months ago, I think. And people start to put more waterproof over there, and start to put the bamboo from north. Now the current situation is we try to convince them start from both of the north and the south, and they're gonna meet in the middle. So that's the site imagery. You look at arrow view, start from north, you will see the profile of the city landscape. On the south part, you will see the profile pretty clear. This is the wood structure. Now the wood structure is all completed, and the waterproof is most of them complete. They are doing a testing for the waterproof right now. So this is the main exhibition space, and this is the auditorium space. Those photos took a month ago, so current situation is much better. This space is already enclosed and start to do the interior construction work right now. And you'll see the bamboo panel from north. It create a very interesting lace around this profile. And that's something I'm really interested in is, this is the model shoots we had in the office. And this is the current situation. The quality is always better than the model. So here is a sentence I really like from the thoughts of the construction book. They call the using of a given material should never happen by choice or calculation. It's kind of like Louis Kahn always said, architecture is from non-measurable to the measurable, and then go back to the non-measurable, right? So the construction accords the material in its opening towards light, a means of expression its inherent color. So when the stone is placed upstone, its forms resist in the joints. So we can switch to another way. So when the rafter meets with purlin, the form exists right now. So that's all. Thank you.